Kana, good morning. Today I am going to discuss about the topic finite element analysis. Have you heard about what is meant by FEA?
Yes, sir.
Can you say some applications of FEA?
Knowing the unknown value about an undefined object or something.
Yes. Already in your 5th semester you have to study about the CAD. In your CAD subject we can make some of the designs like by using solid edge and other softwares. Once we can make the design means how we are converted the design into product. So in between we can use the analysis part. Okay. So on that purpose we can study the finite element analysis. How we are doing this kind of finite element analysis? Any idea?
Using softwares.
Using softwares. What are the softwares are available? ANSYS, FEA, FEM, Nastran, and different types of softwares are available. Once the design is converted into real-time product means before going to make that product we can do the analysis part. On that purpose we are studying the finite element analysis. Okay. Actually in our finite element analysis there are 10 steps to be followed to solve the structural problems. FEA means not only solve the structural problems. In your first 3 units we are solving the structural problems, and 4th and 5th unit we are solving the thermal problems, which means the heat transfer problems. So that's why first we have to discuss about the what are the basic steps are to be followed to solve the structural problems. Have you told your DT and all?
Yes.
Already you are knowing the concept of DT. What is meant by DT?
Design thinking.
Design thinking. How we are applying the DT concept in your real-time product or subject or projects?
First we have to find out what's the problem in that. Then we have to derive the solution based on DT 5 steps.
Okay. Generally how to follow the 5 steps. Empathize means we can identify the problems, which means we can collect the feedbacks from the customers or from the workers, customers or employers. From that we can identify the problem. Second stage, define. We can define the particular problem. Then third one, ideate. In that part we can develop the n number of solutions. In our ideate part we can develop the n number of solutions. Then next part, prototype. After find out the solutions we can make the prototype model, and final stage is testing and all. Same kind of procedures we have to follow in our finite element analysis. If you do the analysis of any structure or product or any kind of structural problems, the same kind of 10 procedures we have to follow. Okay. First step is for discretization. What is meant by discretization? The given structure or problem is subdivided into convenient number of elements. For examples, we have to take it as L section or square or any kind of structural shapes. You can take it. We can first one is you can convert or subdivide the convenient number of elements. That is the first step, which is called discretization. Then second one is for numbering of node and elements. We can subdivide the elements. Each corner point is called node and combination of node point is called elements. This is the second step. And third one is for we can select the shape function or displacement function, which means either we can select the linear element or quadrilateral element or other elements. That is, we can decide that the displacement function or interpolation function. First we can take the linear function as the displacement function. This is the third step. And fourth step we can define the material behavior. By what material we can we can make our prototype or some others. We can take the steel or aluminium, any kind of material behavior we can discuss here, like stress strain relationship matrix and all we can discuss in our fourth step. And fifth step is we can find out the finite element equation. This is these general steps. F is equal to K into U. F means generally we can take the problems by applying the loads. We can take the beam means we are applying the either point load or uniformly distributed load or uniformly varying loads. N number of loads are available. So first one is F is equal to K into U. F means force vector. What are the force we have to apply in that particular nodes. Then this is the general stiffness matrix. And then third one is for F is equal to K into U. U means displacement values. We can calculate the displacement of each nodal points for applying load. Okay, Then sixth step is for we can assemble these two finite element equations. We can combine these two things into make the assemble stiffness matrix. Assemble finite element equation. Then seventh one is for applying boundary condition. Applying boundary condition means we can take the cantilever means one side of the beam will be fixed. Fixed means all the degrees of freedom will be arrested. So automatically there is no displacement. Okay, already you are knowing the concept. So on the free end we are applying the point load. So we are having some displacement values. By applying this FEA concept, we want to find out the displacement values and stress strain at each nodal displacement points. That is seventh step, applying the boundary condition. Then eighth one I already told, we can find out the unknown displacement value at each nodal point. We can segregate the two elements means we can find out the displacement value at each nodal points. Then ninth one is for we can find out the stress strain, and the last step is for interpretations of results. What are all the results we have to follow? Okay. If any doubt in this regarding? Okay. Thank you.